On 2nd July 1937, Amelia Earhart and her navigator Fred Noonan disappeared without trace in the Pacific during their flight around the world. This film presents the theory that they were given an incorrect wind forecast. The evidence for this is in the weather reports and in the testimony recorded in the US Navy report, which was compiled after the unsuccessful search. The effect of the incorrect wind forecast was a 2-degree left heading error. The actual wind then caused an additional 4-degree left drift, and that uncorrected 6-degree track deviation over the whole route was sufficient to put them fatally off course. Their route is deduced from analysis of the radio messages, which indicate what happened as they approached their estimated time of arrival for Howland Island and commenced a search for the island. Born in 1897, Amelia Earhart was an American female pioneer aviator. She learned to fly in the 1920s and embarked on a career of air racing and record making. In 1937, aviation was becoming mainstream, with safe and reliable air routes being set up all over the world. The age of heroic pioneers was coming to an end as Earhart set off on a final great flight. She would be first to fly around the world at the equator. She acquired a Lockheed Electra 10E, which was one of the most advanced aircraft of the time. Of all metal construction, it had two Pratt & Whitney engines of 550 horsepower, retractable undercarriage, and was fitted with an autopilot and the latest radio equipment for communication and navigation. The initial plan was to fly from east to west, starting from California and crossing the Pacific via Hawaii and Howland Island to New Guinea. In addition to Earhart, the crew comprised Paul Mantz, Harry Manning, and Fred Noonan. Mantz was Earhart's mentor and instructor on the Electra and would be second pilot on just the first leg. Manning was a sea captain and navigator and would be the radio operator. Noonan was also a sea captain and navigator and had lately been the chief navigator at Pan American Airlines, which had recently set up new air routes in the North Pacific. Flight from Oakland to Hawaii went well, but during the takeoff at Honolulu for the next leg to Howland Island, the Electra crashed and was badly damaged. Fortunately, there was no fire, and the aircraft was shipped back to California to be rebuilt. Manning dropped out of the Enterprise, leaving just Earhart and Noonan, and they replanned the journey going west to east. During the rebuild, one of the fuel tanks was taken out, reducing the fuel capacity to 1,151 gallons. Neither Earhart nor Noonan were competent Morse code operators, and Earhart preferred to rely on voice communication. So the radio installation was modified by removing the Morse code keys and the low-frequency trailing aerial. Unfortunately, voice communication was difficult on high-frequency radio, and the universal calling and direction finding frequency was 500 kilocycles in the low-frequency band. The dorsal high-frequency aerial was altered, and its efficiency on high frequency was reduced, and it would be useless on low frequency. Later, this would prove to be critical. They were ready to go again on the 20th of May 1937. Their route would take them from California to Florida, across the Caribbean and down the coast to Natal in Brazil. From there, they crossed the Atlantic to Dakar and flew across Africa and the Far East to Port Darwin in Australia, and then on to Lae in New Guinea. After Lae, they intended to land to refuel at a small coral atoll called Howland Island, which was about halfway to Hawaii. After Hawaii, onward to California. The US Coast Guard positioned a ship called the Itasca at Howland to assist with refueling, radio communication, and direction finding. The US Navy positioned the USS Ontario halfway to Howland to act as a radio picket ship. They rested a few days in Lae while the aircraft was serviced, and Noonan waited to get a radio time signal for his chronometers. The US Navy at Pearl Harbor, Hawaii, issued a forecast the evening before departure. It would be partly cloudy with cumulus cloud up to 10,000 feet, good visibility between rain showers with strong squalls 250 miles east of Lae. The wind during the first third of the flight was forecast to be east-southeast 12 to 15. In the middle part, it would be east-northeast 18, and in the final part of the flight, east-northeast 15. This begs the first question. Why did the Navy forecast the wind backing to east-northeast when the prevailing wind at the equator during the northern summer is southeasterly? More on this later. At Lae, the tanks were filled with 80-octane gasoline. One tank was already part full of 100-octane fuel for extra power at takeoff and was not filled, leaving the fuel load approximately 50 US gallons short. Total fuel was therefore approximately 1,100 US gallons. The flight from Lae to Howland would take them eastward across the international date line, and they would lose a day. The planned flight time was 18 hours 49 minutes to arrive at Howland at 7:19 local on the morning of the 2nd again. Local time at Lae was Greenwich plus 10 hours. Local time on Itasca at Howland was GMT minus 11.5 hours. They set off on the 2nd of July at 10 a.m. local time, which is 0 hours GMT, so that GMT is also the flight elapsed time. Takeoff should not be too early because of sunrise at Howland at 5:45 local, but not too late because of the need to avoid the high air temperatures and thunderstorms after midday at Lae. To analyze the flight, the important tracks and radio reports are plotted on the chart. Lae and Howland are shown, and the track between them is 078 degrees true. Waypoints 1 to waypoint 10 are marked at 200 nautical mile intervals. The flight plan was prepared using the known aircraft performance, the fuel plan recommended by Lockheed, and the weather forecast available to Noonan. This gives timings which can be compared with the radio reports. Fuel used and the reserve are also calculated. Earhart's position reports received by radio at Lae are confusing, but there is an explanation. Local radio interference prevented signals from the Electra being intelligible until 4:18 GMT. The Lae operator heard Earhart on 6210 kilocycles saying, height 7,000 feet, speed 140 knots. The operator asked Earhart to repeat the position, but he could not make it out. This would have been when they were between waypoints 2 and 3. The first position report received by Lae at 5:19 GMT was height 10,000 feet, position 150.7 east, 7.3 south, cumulus clouds, everything okay. This is position 150, 20 degrees right of the direct track and south of beam waypoint 1. It is an offset position to avoid the bad weather east of Lae. However, it is only 200 miles from Lae, and when reported by Earhart at 5:19 GMT, gives a ground speed of 39 knots, which makes no sense. The time for position 150 should have been approximately the time for waypoint 1 at about 1:52 GMT. To explain this, an additional waypoint is inserted, position 156, 80 miles south of beam waypoint 3 at 6.1 degrees south, 156.9 degrees east. This creates a track parallel to the direct course. After position 156, the offset converges to 20 degrees and puts them back on track at waypoint 4. The ETA for position 156 is 0509 GMT, the same time as for waypoint 3. Now we can see what happened. Lae missed the original report at position 150 due to radio interference. Then at 5:19 GMT at position 156, it appears that Earhart radioed the wrong coordinates. That is, she gave the coordinates for position 150 instead of those for position 156. So, a minor mystery solved. The next report received at 7:18 GMT was position 4.33 south, 159.7 east, height 8,000 feet over cumulus clouds, wind 23 knots. That's position 159 on the chart. How did they work this out? The dead reckoning estimate for waypoint 4 was 6:53 GMT. At that time, they set course for waypoint 5. After 6 minutes, at 6:59 GMT, they must have passed the Numanu Islands group, 30 nautical miles short of waypoint 4, and seen them through a break in the clouds. Based on this observation, the new ETA for waypoint 4 was calculated to be 7:14 GMT. The 21 minutes time difference between the two estimates for waypoint 4 gives an additional headwind of about 8 knots, which is added to the forecast of 15 knots to give a total of 23 knots headwind, which is what Earhart reported. All subsequent ETAs were then increased by 21 minutes. This was the first indication that the wind was not as forecast. How would that affect the rest of the flight? The effect of the increased headwind would be easily accommodated by the reserve fuel of about 3 hours. And with the expectation of radio and astro fixes, the best course of action was to continue with the flight plan. However, if the wind did not back east-northeast as forecast, the effect would be to amplify the track error, as will be seen later. What can we deduce from the height reports? The fuel plan, revised by telegrams from Curly Johnson at Lockheed, required a progressive climb to 10,000 feet, taking 9 hours. According to the radio reports, they climbed to 4,000 feet and then to 7,000 feet at 4:18 GMT and reported at 10,000 feet at 5:19 GMT. So they climbed faster than planned, reaching 10,000 feet in 5 hours instead of 9 hours. They then descended to 8,000 feet at 7:18 GMT. The most likely reason for this was that they were in cloud at 4,000 and 7,000 feet and in icing at 10,000 feet. The temperature at 10,000 feet is about -5 degrees centigrade, which will pretty much guarantee airframe icing when in cloud. Airframe icing will increase drag and weight and fuel consumption, reduce propeller efficiency, block the air intakes and the pitot-static system, obscure windows, and interfere with radio signals. Carburetor icing will reduce power. They had to avoid ice at all costs, so they descended to 8,000 feet. They may have tried 10,000 feet again later, although Nauru Island had reported cloud and Itasca at Howland had reported high cloud. The PBY flying boat that was sent to assist with the search later reported cloud and icing between 2,000 feet and 12,000 feet. So all the indications were that there was high cloud, which would obscure the stars during the night. Sunset occurred when the Electra was near to waypoint 5, so that the middle part of the journey was in darkness and likely still cloudy, making the use of the drift site difficult. No two-way radio communication was achieved and no radio bearings were given. It is unlikely that the aircraft direction finder was working, as Earhart had not got a bearing with it during the test flight the previous day. A high cloud cover and possible ice on the small side windows probably made astronavigation difficult. Noonan needed 3 good star shots to work out a fix. Had he achieved that, he would have corrected his track and revised the wind forecast. The fact that he remained off course indicates that he did not achieve a fix. Why did they not turn back? Point of no return with an easterly wind is about halfway, at about 0900 GMT. ETA back at Leh would be about 2 a.m. in the morning local time. That means that they would have to renegotiate the squalls and make a night approach and landing at Ley with surrounding high ground in darkness. Not a good prospect. So they pressed on to Howland with the expectation of a homing signal from Itasca. In part 2, the radio messages received by Itasca are analysed and a conclusion is drawn.